From Microbe TV, this is TWiP, This Week in Parasitism, episode 157, recorded on August 28th, 2018. I'm Vincent Racaniello, and joining me here in New York City, Dickson Despommier.
Hello, Vincent.
And from a remote location, Daniel Griffin.
Hello, everybody.
Hello, Dan.
Boy, is it hot out.
Oh, yes.
It is outrageous.
Yes.
Is it really outrageous there as well, Daniel?
It hit 100 degrees today.
Whoa.
Well, I mean,
Whoa.
I could see you guys from basically where my remote, so we're not that far away. So the weather is very similar, but I feel like sometimes it can be hotter in the city because the concrete everything holds the heat.
We got a bubble.
Yeah,
It's 35 Celsius here. This is wow. It hasn't been
It's
35 in a long time.
It's tropical.
I love it.
Could fry an egg on the hood of a black car.
All right, we have to start. We have a few follow-up emails from the last episode. I thought we would put these up front here.
Mm-hmm.
First one is from Anthony, who writes, mention of level 1 healthcare practitioners in TWiP 156. Did we mention level 1?
we did. We didn't call them level 1, but we talked a bit about certain parts of the world will train the medical corps at a very basic level so that they don't end up getting their MD and then, migrate to England or something.
I did talk about that.
So it's something that goes on in a lot of parts of the world, as we're going to see a little bit here.
All right. So Anthony continues, that brought to mind a short newspaper article that I read perhaps in 1965 about China's barefoot doctors. Googling that, I learned they were preceded by an avant-garde of parasite fighters. He sends a link to an NPR article from November 2005. This is 13 years ago.
Parasite
Health for the masses, China's barefoot doctors.
Yeah.
When doctors and money are in short supply, how does a government provide health care for its people? Brenda Wilson has reported that at a time when they're needed most, physicians and nursing from developing countries are being recruited away in large numbers by Western countries. On the eve of the 1949 Communist Revolution, China found itself in a similar situation. China estimated that there are about 40,000 physicians trained in Western and Soviet medicine, serving a population of 540 million people. 10 million of these peasants suffered from big belly, the peasant name for schistosomiasis.
Right.
Anyway, it goes on to talk all about that, how they fixed their health force. Are you familiar with this, Daniel?
So I am, and I have to say, when you talk about the big belly disease, I was shocked. So it was in 1988, which was the first time I was in China. Our listeners probably don't know, but I actually studied Mandarin when I was younger, and at one point was asked to work in Kunming. And so this is the late 80s when there isn't really a lot of openness in China for U.S. citizens to come and visit. And I ended up in southern China, and I was in the Guilin area, which is spectacular, I should say. And I think it was 89 when I remember this conversation in Guilin where they knew, I thought it was hilarious, but we ran into some people. They were supposedly students. I'm sure they were spies, just keeping track of us because their English was much too good. But no, we were speaking to them, and they knew the word schistosomiasis. They said, "Oh, schistosomiasis." They knew all about it and the water. It was very interesting because most people in the U.S., you bring up schistosomiasis, and other than perhaps our listeners, maybe would not be as knowledgeable as these young students were.
Interesting.
Ni hao ma.
Oh, how?
And how?
Next
okay, Octavio writes, Dear Professors, a few weeks ago I was delighted to hear about Charles Donovan, for he is one of my favorite characters in the history of biology. I do not want to seem to have the hubris to correct Professor Despommier, but I would like to ask permission to add just a couple of notes to the story that was told. The first modern record of a cutaneous lesion cutaneous lesions caused by leishmania was made by Cunningham in 1885, who described the presence of bodies, in quotes, inside what would probably be macrophages. He thought that those could be spores of mycetozoa, an amoeboid somewhat similar to fungi. 4 years later, in 1898, a medical officer of the Tsar's army named Pyotr Fokich Borovsky observed in microscope preparations of sarboil, one of many names given to cutaneous leishmaniasis at that time, many particles with 1.5 micrometers in diameter, which contained one nucleus and a process that pointed to the periphery of the body. He correctly identified the organism not as bacteria, but as a protozoan, and produced a correct description of its morphology, including the kinetoplast, and published it in that same year of 1898, 5 years before the article of Donovan, Leishman, and Ross. But as the article was printed in a medical military journal with little circulation written in Cyrillic, it fell into oblivion, and the rest of the scientific community maintained the belief that these Baghdad boils, Aleppo, or Bach sores were caused by some kind of bacteria or fungi. At the end of the 19th century, there was a urge to find the reason behind the problems that afflicted the villages from Garo Hills east from the Brahmaputra River in the Assam province of India. There, more than 123,000 people died, what resulted in intense depopulation and lack of workers to the tea plantations. This interest, driven by economic reasons, because the tea production was of uttermost importance to the British Crown, left to the suspicion that the culprit was an intestinal parasite identified by Otto Wucher, a German ascendisary born in Portugal, medical doctor. He was a medical doctor who went in to live in Salvador, Brazil. He identified the parasite Encelostomum duodenale, which was the first suspect to cause the very high mortality rates in that region of Assam, as reported by George M. Giles in 1889 in a report of an investigation into the causes of the disease known as Assam as Kala-Azar and beriberi. Dobson disputed the theory, arguing that Kala-Azar affected people that had anemia but also splenomegaly, and that was not found in cases of ankylostomiasis, indicating it might be some form of malaria. The discussion between malariophiles and the proponents of other causes continued until the story told by Dr. Despommier, where William Boog Leishman performs the autopsy of an Irish soldier who died after spending 7 months in the Royal Victoria Hospital at Southampton, England, in consequence of falling ill during his commission in Dum Dum, near Calcutta, India. As before him, Borovsky also did. In that year of 1903, he described the larger mass of chromatin of the nucleus and a smaller one in the shape of a small rod, perpendicular to the circumference of the large mass, but concluded no more. Only 3 years later, while examining a dead rat infected with African trypanosomes, he noticed that the similarity between those and the bodies in the soldier's spleen, and those were also degenerate trypanosomes, and thought those were also degenerate trypanosomes. Donovan, nevertheless, considered those were not artifacts nor degenerated trypanosomes, for he observed smears from a fresh spleen biopsy from an Indian boy who had irregular fevers. After consulting with Charles Louis Laurent, Nobel Prize winner in 1907 for work on malaria, and Felix Etienne Mesnil of Mesnili, and there's an organism named for him too, he wrote that those bodies must be a third entity still unknown. The French scientists concurred and even proposed the name Pyroplasma donovani, but Ronald Ross criticized the French conclusions, made another description of the entity, and proposed the creation of a new genera, Leishmania, in the Sporozoa class, and the name Leishmania donovani for the newly identified agent, the Salmonic solution recounted by Dr. Despommier. Donovan did correctly identify the agent first, or second after Borovsky, than Leishman, but he also made another tremendous contribution. He observed that in 93% of the moderate and severe cases, the parasite was found in the monocytes and in the polymorphonucleate leukocytes, becoming evident that the spleen punction, which was a highly risky procedure at the time, was not necessary to give a diagnosis. In other words, you shouldn't biopsy the spleen. This was supposed to be just a small addenda to the story of Donovan, so please forgive me the too many words. This was fantastic. Edit, cut it, and paste, but don't even bother to read this in the podcast. Just add the curious fact of Borowski, a proof that it is not only needed to publish, not to die, but it is also necessary to do it in the proper journals, and the contribution of Charles Donovan to the diagnosis of leishmaniasis. Yours always, grateful fan, Octavio, and he's a veterinarian, and he lives in Portugal. That's a great letter. Thank you so much for filling in the blanks.
There's always another story behind this.
There is, I know, of course. And that's great.
And Charles Darwin wasn't the first to propose natural selection.
No.
Wallace
that's
did it
right.
at the same time, but he didn't publish in the right journal.
Even before that, some other people had suggested it, but then they screwed it up by hypothesizing in the wrong direction afterwards. But
Daniel, can you take Catherine's, please?
Certainly. Catherine writes, hello, I am a listener along with my 83-plus-year-old parents, just so you're aware of the age range of your audience, and wanted to comment after a recent episode alluded to poetry and parasites and immunosuppression. Back in medical school at Cornell in the early 1990s, we had a wonderful parasitology course taught by Dr. Warren Johnson.
Good friend of mine, by the way.
One of my colleagues, Mike Hurwitz, created a limerick that I still remember to this day, and I thought I would share with Dickson. Oh, no. Ode to the schistosome, ode to never being alone, to be with my gal in the gynecophoric canal, in copula, wherever we roam. Yes.
That's a good one. That is a good one.
I think that's one of the things that people don't always appreciate. They say, oh, these schistosomes, look how wonderful. It's the male. He's wrapped around the female, just holding her like that. But they're constantly having sex, right? I mean, they're in constant copula. So
they are.
Yeah. So
oblivious to the world around them. The swirling, whirling world of the circulatory system.
Okay. A small part of a life cycle that was etched into memory via poetry and song. On a different note, Rituxan is a medication used by many providers to treat numerous conditions, from cancer to ITP. That's immune thrombocytopenic purpura. It's basically a disease with low platelet counts, usually driven by antibodies targeting platelets. Okay, by the way, and many other dermatological, rheumatological, and neurological issues. It may have been part of the cocktail that was used in the patient you presented with disseminated strongyloides. So just to give people so this Rituxan is basically an antibody that is against one of the proteins that's on the surface of B cells. So when people get this medicine, for instance, it targets a protein called CD20, which is on the surface of B cells, but not on plasma cells, and it can deplete them. So, as she continues, a B cell depleting agent, it is known to cause reactivation of hepatitis B virus. That could be clinically fatal in some situations. I was wondering if you were aware of many Rituxans or how Rituxan use may impact both serological testing, results for microbial or parasitic infections, or clinical reactivation of other non-HBV infections. Immunosuppression is changing rapidly, and often we are finding out after the fact how and what our immune cells are doing for us. Thanks for the great shows, Katie.
Interesting.
That's a question for you, Daniel.
Yes, it was. Ball is in your court now that the U.S. Open is on.
Yeah, it's interesting, actually. And I'll go a little into more of what was saying. So we have a lot of these immune modulatory therapies now. I have to say, I find this part of my practice enjoyable when I get called to see someone, because a lot of times people on these immune modulating therapies have what we'll say interesting, uncommon infections. And Rituxan, as I mentioned, it goes after CD20, so it's going to deplete your B cells, but it's not going to necessarily target your plasma cells, right? So it's not going to be quite as profound as we have another agent that goes after CD19, which is going to also target your plasma cells. And that's going to be a huge issue, almost like getting a splenectomy, where you're going to end up losing this memory and this protective immunoglobulin shield that has been developed over your lifetime. Basically, it allows, bacteria. It's pretty easy. We talk about the encapsulated organisms, things like pneumococcus. Then when we get into viruses, we don't think it usually plays a large role, but there are some viruses, interesting enough, that actually are kept at bay in part through the effect of immunoglobulins. So as she brings up here, reactivation hepatitis B virus we see. So we'll often have people on a medicine entecavir as a viral suppressant if they're going to have this impact. Some other, I'll say, parasitic diseases, I don't know if we know quite as much about. And part of it, I think, is where in the world these therapies are being used relative to where the parasitic diseases are prevalent. But I think we're only going to learn more and see more of the impact of these on parasitic diseases as the use of these spreads outside the first world into a lot of the parasite endemic regions.
Yeah. Right.
Layla writes, Dear Professors TWiP, we are getting ready to go to the beach for the last week before elementary school starts here in North Carolina. I've never learned how to sail, but we all enjoy taking kayaks, canoes, etc. into the marsh. My brother has been catching lots of flounder this year, and my son is super excited to go with him. I didn't have time to make a case diagnosis with rushing around getting ready for vacation this week, but I learned something interesting that I wanted to share. The evolution of the underground London mosquito, Culex pipiens F. molestus. Supposedly mosquitoes may have evolved to live underground and bite people instead of birds. She sends a link to a Wikipedia page, the London underground mosquito. It's found in the London Underground, but has a worldwide distribution. First described in the 1700s. Continuing with Layla. Do you think this is a new species and that creation of a new species can commonly occur quickly? I don't know what you mean by quickly. I would say depending on the selective forces, it could occur in a year. What do you think? Enough genetic diversity occur in a year in a mosquito to make a new species?
Yeah, they actually did some experiments, not with mosquitoes, but with certain kinds of anole, like lizards, and they released them onto an island, a small island, where there were already anole present, and they were occupying a certain niche, and the new anole had to find a new niche, one that they were totally unadapted for in their old habitat, and they did. And within 10 years, they were occupying places that they'd never lived before. So, and they maintained their species separation this way as well.
It says more recent evidence suggests this is a southern mosquito variety related to C. pipiens that has adapted to the warm underground spaces of northern cities.
Right. New York has it. Boston has it. That's right.
You make a niche, it fills up.
That's nature abhors a vacuum.
I am a postdoc and recently applied for a K-99. My score was not favorable, and I'm out of the application timeline.
Oh, dear.
I've been considering going into industry pretty carefully. Do you have any advice on switching scientific paths? Let me give you some advice. My wife went into industry right out of her postdoc. She had no desire, actually, to go into academics. And she was working on trypanosomes at the time as a postdoc with George Cross, and went to Merck to work on ivermectin, which is not used for trypanosomes, right? But it's still a parasite disease.
That's right. It is.
River blindness, right?
Yes.
What else?
Oh, lots of helminths. Many helminths.
So she switched parasites.
And ectoparasites, like
and
scabies.
That's correct.
So,
that's right.
It's a great drug.
It is.
And, they said we just want good scientists. Every 5 or 10 years, they would change her focus. So she worked on parasites, I think the first 10 years. Then she worked on antimicrobial compounds. Then they switched her to obesity and leptins. And her final years there, she left a number of years ago. She worked on drugs for hypertension. And they would say to her every time, we want you to stay, but you have to change fields. And she said, I can learn anything in 6 months. So you're a good scientist. You can learn anything. Look at it that way. Anyone else have a comment?
No, I think you have to follow your passion, and your passion should be discovery. And there's no better way of suiting your passion up than to go into science. So science has so many different places to go to realize the thrill of discovery that you shouldn't have any problems finding a nice place for yourself.
Yeah, I'll chime in as well because I've bounced around, right? I was in clinical medicine. Actually, for a while, I was working with Amgen and was on the project where they developed an antibody to target a protein that was important, osteoporosis. So the drug Prolia, I was involved in the development of that, and and then academics. And so I think that some people thrive in academics, some people thrive in industry. And I think sometimes there could be a perception that one is sort of better than the other. But I think it really is for particular people. One sort of clicks better than others. And I have to say, I truly enjoyed my time working with Amgen. So
I think if you're independent and you want to be in control, then you should go into academia and, go to the grant route. But if you don't mind being told what to work on, as long as you get to discover stuff and work on science, then it doesn't really matter. Then I think your options are much larger. Okay, Anthony writes, World Mosquito Day, observed annually on August 20th, is a commemoration of British Dr. Sir Ronald Ross's discovery in 1897 that female mosquitoes transmit malaria between humans. Well, that's actually not correct. On his discovery, it's not, and we'll go back to that. On his discovery, he declared that August 20th should be, from then on, known as World Mosquito Day. So
let's look at the article.
Sir Ronald Ross is not credited with discovering the mosquito that transmits malaria to people.
Yeah, this article says that.
Yeah, well, that's
RSTMH. What is that?
The Royal Society for Tropical Medicine and Hygiene.
Yeah, well, they wrote it, not Anthony. So
they should know better because they know that Sir Ronald Ross discovered a mosquito that transmits malaria between birds.
Right.
And the Grassi group in Italy discovered the mosquito species, in this case Anopheles. I believe it's Stephen's eye that transmits it between humans.
Nevertheless, August 20th is World Mosquito.
Yeah, well, that's right. Mosquitoes are mosquitoes, and they do transmit malaria regardless of their hosts. So that's true.
All right, Daniel, can you take that last one, please?
Connor writes, hello, docs. I just wanted to check to see if any of the regulars on the TWiP series are attending the ASTMH annual conference. The podcasts are all recommended listening for multiple of the Tulane School of Public Health and Tropical Medicine courses. My classmates and I would be delighted to meet anyone that opts to go to the conference.
Cool.
Thanks for all you do in science education. And it's from Connor E. Dunn, and he's down there at Tulane University School of Public Health Tropical Medicine. He's an MPH tropical medicine candidate.
Right. So, Daniel, are you going?
When is it? You need to tell me.
It's always in November. It's always in November, and I don't know where it's being held this year. It might be
TMH annual conference. I'm going to Google it here.
It was in Baltimore, the last one I went to, and I actually gave a talk at it. It's a lot of fun.
I mean, you and I actually went, we drove down together.
October 28th, New Orleans. Dickson, you ought to go.
Oh, it's in Nolan.
When's the last time you were in New Orleans, Dickson?
It's a while back. I was in New Orleans the 3 months after Katrina. That's when I was in New Orleans. That's the last time I was there. I went down to help out.
I have no plans to go.
No, I haven't made any plans to go this year.
I can't go.
Oh dear.
Right, so not yet. But let's see. The next year, though, it's back in Maryland.
Right.
Why don't we go and do a TWiP one year from it? Would that be appropriate?
That would be fabulous.
We have to get in touch with whoever's running it. And
that's easy. We know people.
You know people?
We know people.
Okay, good.
Yes, we did. So let's try to get there for the 68th annual meeting in 2019 down in Maryland.
That'd be good. Yeah, we can do this.
I guess the next one is going to be in Toronto. I just got back from Canada.
Right. How was that, by the way?
It was spectacular. And I was canoeing. I was thinking of it when we were
nice.
We're in Montreal and north of Montreal in Mont Tremblant. We did a lot of hiking, canoeing, zip lining. It was beautiful.
Was that in the Laurentians?
Look at him. He goes outdoors.
Of course. Come on. He's an outdoor guy.
I've been outdoors all summer.
He was at Colorado State University for many years, remember? And that's an outdoor place.
You fish.
I do.
I don't do anything. I cut the grass.
It's outdoors.
I had a coach who used to say when he wanted to experience the outdoors, he'd crack a window, and when he was done, he would shut it. So,
what was he coaching? Speech?
It was cross country running.
Cross country running.
But he would follow us in his car, the windows rolled up and the air conditioner on. But
right.
All right, it's time for our case.
It is.
Tell us about our case, Daniel.
Oh boy!
All right, as I like to say, for those of you clicking back in or those of you clicking in for the first time, our case from TWiP 156. While on the ID consultation service on Long Island during July, so this is very recent, we're asked to see a woman in her late 70s who's admitted for fever, confusion, diarrhea, 2 to 3 days of abdominal pain, nausea, some vomiting. The history goes that the week prior, she was at a family party and she drank 2 glasses of scotch. Did I say large last time? I don't know. It's hard to know what large is. Had watery, non-bloody diarrhea 4 to 5 times per day. She had some vomiting 2 to 3 times per day. She actually had a fever up to 103 F, right? So that's going to be about 39 C. Headache, lost appetite, 4 to 5 days, didn't eat. She ends up getting hospitalized. And no one else at the party became ill. So you try to get a little more history there. She originally, she says back in 2005, she had an episode of turning yellow when she visited Nepal. Okay, so it sort of raises some issues. Why is she visiting Nepal in 2005? No surgeries, no allergies, no diseases running in the family. But she does actually have that disease we mentioned, the ITP, the immune thrombocytopenic purpur. So she's on prednisone for the treatment of that. We also mentioned she'd been on some other medicines, but her social history was what got a little bit interesting. So she was born in West Bengal, India. Then she moved to Kathmandu as a teenager, and she lived in Kathmandu until her 50s. And she lived over on New Road, which is really like a sort of succeeding, sprawling, thriving retail section. And her family owned a retail shop there. She had moved to Long Island 25 years before, but she returns periodically to Nepal and stays with the family there. And she had this episode, as she mentioned, 2005, where she turned yellow. They basically said it was hepatitis, but no one really clarified what that was. And the last time she had been there was about 2 months before. She was 2017 for 2 months, right? So it's been over a year, but about a year. And then we also got a little more earlier this month. She had done a 3-day camping trip, which was pretty impressive for this woman in her 70s. She slept in a tent with her family. I guess the whole large family went together to a camping site on eastern Long Island. They brought water to drink, so they weren't drinking from any streams or anything. They didn't mention any contact with animals out there. And on exam, her liver was a little small on percussion. She didn't have an enlarged spleen. There was actually fluid. She had a bit of ascites, at least by exam. So the belly was a little bit distended. Her white blood cell count was elevated at 38,000, but there were no eosinophils, so eosinopenia. She had a CAT scan of her belly, which showed a small cirrhotic liver, some acidic fluid. And then we got one sort of, I'll say, critical result. We get a report back on the blood smear that they are seeing intracellular ring forms just less than 4% on the smear.
Right.
All right, Daniel, why don't you start off with that first guess?
Alexander writes, hello all. I was kind of saddened hearing about how some people might be undertrained, leaving them with fewer job opportunities. As while I was learning about forestry, my professor always stressed the importance of having something to fall back on when newer techniques don't work. I remember hearing that with the old aerial photography, you could actually count each individual tree, and learning how to measure structures from the same photography. Well, now you are more limited by the pixels in the image. I still have a yardstick that I can use to measure diameters and heights of trees without having to use any specialized tools. For this case, though, given the possibility for a Babesia infection, I wanted to keep that in mind that it can produce rings in 1 to 10% of the red blood cells that is described in parasitic diseases, page 176. However, pretty much any time you all mention Babesia, the Maltese cross comes up. So I wanted to put that one on back burner. I also thought about Plasmodium vivax or P. ovale, given the history in India, given that fever, abdominal pain, diarrhea, and vomiting are present. In parasitic diseases, page 113, I read that usually only about 2% of red blood cells are parasitized and there is no eosinophilia. Given what I was able to at least narrow down to P. vivax ovale, which I guess can be differentiated by Schuffner's dots or James's dot. Is there a difference? I would suggest chloroquine as a treatment. Mm-hmm. So let me actually answer that last little question. So Schuffner's dots versus James's dots.
Yeah.
Now that is actually a little esoteric, but I'm still going to answer. I find this a little bit challenging, right? When I'm asked to distinguish vivax from ovale on a blood smear. Now, falciparum, right, is usually easier to distinguish in part because sometimes you'll see higher percentages of parasitemia. Sometimes you'll see multiple parasites in a single red blood cell. Rarely will you see gametocytes.
Correct.
Now, with vivax and ovale, you tend to see more forms in the peripheral circulation. And sometimes the red blood cells will have this sort of stippling, these little dots. And they say, well, if it's Schuffner's dots, then you know it's ovale. And if it's James's dots, then, or the other way, if you know that then you know it's vivax. If it's James's dots, because they're slightly larger. Well, unless you have the two sitting right next to each other, right. I'm not sure I can tell. Right. I just see, and I've got this wrong on tests. So I'm always sort of annoyed that I'm expected to tell, I guess if I had a cheat sheet in front of me, which is actually what you should have in the parasitology lab, right? A cheat sheet to look at. So that's the difference. The Schuffner's dots are smaller, and the James's dots are darker and slightly larger. And so, one of the Schuffner's is ovale, the James's dot are the two types of, so the Curtis, the Walkeri. So. Yeah.
Okay, we'll come back to that too, because I used to teach this subject and I never got involved in that differentiation overall.
You didn't do James's dot?
No, we never did that. We did it on geographic distribution more than anything else. So Hannah writes, Dear TWiP hosts, when you mentioned intracellular ring forms, I immediately thought of malaria. The fever and the gastrointestinal symptoms fit that diagnosis, but some other aspects of the case don't add up. P. vivax and ovale can both relapse and are found in Nepal, but according to parasitic diseases, usually about 2% of red cells are parasitized with P. vivax and P. ovale infections. I had a feeling I was missing something. Remembering that there was also a North American parasite with ring forms in the blood, I searched the textbook and found it. Babesia. Infection with Babesia species can result in headaches, fever, and gastrointestinal symptoms, and it is more severe in people with suppressed immune systems. 1 to 10% of red cells are typically parasitized, so that fits, and Babesia species are known to be vectored by ticks on Long Island. A co-infection with Ehrlichia, which is vectored by the same ticks, would explain the high white count and confusion. It can also cause flu-like symptoms like fever, headaches, vomiting, diarrhea, and the lack of appetite. And the timing, a very recent camping trip, fits too. Ehrlichiosis tends to show up within a couple of weeks of infection. This will probably be the last email I will write you from Berlin, where it's 22 C tonight, but daytime temperatures have been well over 30 C, even climbing to 37 C earlier this week. That's body temperature. By the time the next episode airs, I will be in Ottawa, where I will soon be starting a PhD at Carleton University looking at how cold stress impacts insect physiology. I won't be working with any parasites, unfortunately, but I do find insect parasites, both parasites that are insects and parasites of insects, really neat. Here's a paper about flies that live in termite soldiers' heads and emerge through their hind ends, and he lists the reference. And I think you'd enjoy talking about strepsipterans, that's his twisted-winged parasites, and the Acrocertiae, the spider flies as well. Before I sign off, an anecdote from when I was an undergraduate in a parasitology course that I took. The professor acquired some dead hedgehogs and fish, just ordinary wild animals with no known history of disease, and told us to dissect them and look for parasites. What really stayed with me was her confidence that we would find parasites, and of course we did. All the best, Hannah.
Let's see what this paper is. That Hannah.
You're driven by curiosity. I love it.
Well, yes. When our listeners send us things, we should look, right? This is the Journal of Insect Science.
That's right.
The parasitoid Rickettsia fasciventris causes morphological and behavioral changes in infected soldiers of the fungus-growing termite, Macrotermes carbonarius. Right. Wow. So they cultivate fungus.
Yes.
In gardens.
Yes.
And these poor ants get their behavior changed by a parasitoid.
Well, the soldier flies, these are not soldiers like, enlisted in the army or something. These are called soldier flies.
This is pretty cool.
Yeah.
I think we should do this.
You do,
because it's it's like Alien, zombie.
One parasite on top of another.
Jessica writes, hello, TWiP professors. My guess for case study 156 is babesiosis acquired during the camping trip earlier in the month. My true reason for writing, though, is to suggest the topic of Cyclospora cayetanensis. There have already been several large recalls from major food manufacturers and a recall from a large food service chain. The current outbreak's recalls open up a lot of questions with not a lot of answers. I've been eagerly tuning in every week, waiting for you guys to discuss. The weather in Chicago this evening is about as ideal as weather could be. I'm very happy to report. Thanks for a great podcast, Jessica. We will talk about Cyclospora, okay?
Yeah, we will do that. That's definitely.
We'll do an outbreak update and talk a little bit. It's on our docket. Okay, very good. I'll make a note. Daniel, the next one, please. Oh, here's Kevin. Okay. There you go.
Okay. Yeah, this is a long one, isn't it? Okay. I think he even uses a smaller font so I could fit it all in.
Exactly.
Now, Kevin writes, Chicago weather, high summer, hot sun, dry, dogs panting.
Sounds like a haiku poem.
Okay, acutely ill, elderly, late 70s woman with a febrile illness plus anorexia, nausea, vomiting, diarrhea, and dehydration. The time course is important in order to consider incubation periods of illness. Patient went camping approximately 3 weeks prior to the onset of her illness. Pre-existing illnesses relevant to our presentation. Cirrhosis with portal hypertension and varices. Cirrhosis is also regarded as an immunocompromised state. Glucocorticoid immunosuppression, prednisone, high daily dose. Immune thrombocytopenic purpura. History of self-limited jaundice in Nepal 13 years ago. Could view chronic thrombocytopenia as a partial immune deficiency due to the recognized role of the platelet in immune function. Immune risks, immunosuppression, foreign travel, foreign birth, camping in known tick-infested location, high-risk activity, high-risk geography, high-risk season, age greater than 65, age-related decline in innate and adaptive immunity, highly relevant data, microscopy showing less than 4% intraerythrocytic inclusion bodies, specifically ring forms. Despite the patient's complicated past medical history and comorbidities, intraerythrocytic ring forms point to two diagnoses, both being infections by the members of the protozoan phylum Apicomplexa, malaria and Babesia. The 2018 CDC Yellow Book states that there is no malaria transmission risk in Kathmandu. Hence, malarial ring forms can be dismissed as a possible diagnosis. Additionally, the history strongly suggests a recently acquired infection, which leaves the culprit organism as Babesia species. There are as many as 60 Babesia species, though the most commonly acquired type in USA disease is B. microti. It is transmitted by the colloquial named black-legged or deer tick, Ixodes scapularis. The tick also transmits the spirochete Borrelia burgdorferi, Lyme disease, and the rickettsial organism Anaplasma, phagocytophilum. Note that anaplasma might be associated with morula, intraerythrocytic inclusions. Though not a diagnostic possibility here, it should be noted that there are rare, non-infectious intraerythrocytic inclusions called Cabot rings, which are ring-like structures that can be seen in erythrocytes in megaloblastic anemia or other severe anemias and lead poisoning. Other potentially distracting RBC inclusion bodies are well illustrated in a reference below. The incubation period for babesiosis is between 5 and 30 days, which is consistent with our patient's illness. Diagnosis is via immunofluorescence assay, IFA, for Babesia IgM, and PCR for the 18S ribosomal RNA gene. Treatment for Babesia in the immunocompetent patient is atovaquone and azithromycin. Immunocompromised patients, or in those with more severe disease, IV clindamycin combined with either oral quinine or IV quinidine. Co-infection with Borrelia and Anaplasma is a distinct possibility, and in view of patient's age, immunosuppression, and coexisting illnesses, empiric therapy for these infections would probably be prudent, notwithstanding her relatively low-level Babesia parasitemia. Some feared complications of babesiosis. A review of 34 cases of babesiosis who were hospitalized in Long Island states that acute respiratory failure is the most common complication, 7 of 34 cases, followed by disseminated intravascular coagulation, DIC, 6 of 34 cases. An uncommon but very severe complication is acquired hemophagocytic lymphohistiocytosis, HLH, which is an excessive inflammation, hypercytokinemia, abnormal immune activation, and tissue destruction. I could not find any information that implicated prednisone or ITP as being unique risk factors for Babesia complications or severe disease. Though not applicable to our case, splenectomized patients are at high risk for aggressive disease, high parasitemias, and increased mortality. An interesting association I encountered while researching this case is that a Babesia infection can be associated with inducing immune thrombocytopenic purpura in persons with no prior ITP history. Finally, the leukocytosis is concerning, especially in light of the fact that leukopenia is frequently seen in babesiosis, and high prednisone is typically associated with lower or moderated WBC counts. However, in a 1998 New York State review of 139 Babesia cases, a white blood count above 5,000 was a negative prognostic factor. The WBC elevation also again raises the possibility of dual infection with Borrelia and Babesia, where leukocytosis has been described. The high white count must also stimulate a heightened vigilance for sepsis, abscess, spontaneous bacterial peritonitis, and other bacterial infections, and hematological problems such as incipient leukemoid reactions or early-stage CLL. Incidental info red herrings. Her episode of jaundice 13 years ago could have been due to hepatitis E, which is hyperendemic in Nepal. She should, of course, be tested for Hep C, Hep B. Autoimmune etiologies of her cirrhosis should also be considered. I don't consider any of this directly relevant to her acute illness, other than contributing to a burden of pathology in the elderly. I regard the 2 glasses of scotch as incidental and not a cause of her cirrhosis. And of course, a standard alcohol history should be obtained, but a regrettable rush to judgment should be avoided. The symptoms of nausea and vomiting are likely constitutional symptoms associated with her primary illness, babesiosis, and should not lead us to an intestinal diagnostic morass. GI symptoms are less common in babesiosis, but have been described in a 1977 review. Finally, an offshoot of the ixoid tick discussion above, I'd like to put in a plug for the inclusion of a brief mention of tick-borne encephalitis virus in Chapter 39 for your revisions to parasitic diseases. I became acquainted with this disease while discussing ticks with some Latvian artists who I believe have been vaccinated for it. The East still has its mysteries. What a long, strange TWiP it's been. Thanks.
Lovely. That's a good one.
Fabulous.
That was an excellent email.
And a long, strange TWiP
amazing.
It's been. Yes, I remember that song.
That's right. Wasn't that by the band?
No, Crosby, Stills, and Nash.
Oh, okay.
What a long, strange trip it's been.
Grateful Dead. No.
Alexandra writes, Dear TWiP team, here goes my first case diagnosis. When I first heard the case in 156, I thought the woman was infected with Plasmodium vivax. Vivax parasites can remain dormant in the liver for years before being released into the blood, so she could have been infected while in Nepal in 2017. Too high up, you said, huh, Dickson?
Well, Kathmandu is, but there are other parts of Nepal. She had to go through a process to get there.
Another possible diagnosis is babesiosis. vivax, transmitted by ticks. B. microti, most common species in the U.S., prevalent in the Northeast, could have been infected during her camping trip. B. microti parasites are transmitted by the nymph stage of the Ixodes scapularis tick, which is about the size of a poppy seed, so she might have been unaware. This in the previous email, we're getting all the background on Babesia that we need for our paper.
There you go.
Right?
Pretty relevant.
Remember, nymphal stage.
That's right.
The woman's symptoms of fever, diarrhea, nausea, vomiting, and appetite loss could result from infection with either P. vivax or B. microti. Both of these infections are generally associated with normal or low WBC, but this woman's high WBC could be attributed to the fact that she's on prednisone. While P. vivax is present in some parts of Nepal, not in Kathmandu,
right.
area she reports visiting. For this reason, I believe the most likely diagnosis is B. microti. Based on PD6, most people with Babesia have 1 to 10% parasitized RBC, and her level of 4% fits. Many people are asymptomatic, but her clinical manifestations could be due to her immunosuppressed status because of taking prednisone. Confirmed diagnosis, re-examine the blood smear, look for tetrads of merozoites forming the Maltese cross that is characteristic of Babesia and helps distinguish it from Plasmodium. Also do PCR. Women should be immediately started on treatment for severe babesiosis, which according to PD6 is intravenous clindamycin plus oral quinine or IV quinidine. Conveniently, these drugs are also effective against malaria. Thanks for a great podcast. Alex is a post-bac fellow at NIH.
Nice.
Here we go.
Kendra writes, hello all. The weather in Casper, Wyoming is sunny and 99F.
Whoa.
Which, with much cooler weather predicted for the next couple of weeks. My guess for case 156 is Babesia microti. It is probable that the woman in her late 70s was bitten by a tick during her 3-day camping trip with family in Long Island. The parasite is commonly found in the northeastern part of the United States, particularly in Suffolk County, eastern Long Island. B. microti is spread by Ixodes scapularis ticks. The young nymph stage of this tick is very tiny, and a bite by this tick may go unnoticed. I suspect Plasmodium falciparum as a possible diagnosis due to intracellular rings found in the blood smear. However, I did find that in areas where P. falciparum and B. microti are found together, B. microti is often misdiagnosed as P. falciparum, as the pleomorphic rings found in B. microti blood smear may be confused with the intracellular rings of P. falciparum. Upon viewing a blood smear positive for P. microti, it is typical found that 1 to 10% of the red cells will be infected, and there will also be extracellular rings present, which are not found in P. falciparum. I did initially suspect schistosomiasis as well due to the cirrhotic liver. However, the podcast did state that she had a past history of cirrhosis, fatty liver, and a history of drinking a large amount of alcohol in one sitting. B. microti can be diagnosed with a right or game-sustained thin blood smear and or by PCR. The treatment of choice is atovaquone / or zithromycin. In addition, I would perform PCR assays to rule out the co-infections with ehrlichiosis and or anaplasmosis. I suspect her symptoms of diarrhea and confusion are due to the co-infection. Best wishes.
Lots of references.
Many references.
All right, Daniel.
David writes, Dear hosts, after taking a few weeks off of guessing the case study diagnosis, I think I will venture a guess this time around. I believe the woman from Nepal in her late 70s is suffering from complications due to Plasmodium vivax malaria. This form of malaria produces an interesting life cycle stage known as the hypnozoid, which can stay dormant in the liver long after the initial infection. The patient's fever, jaundice, nausea, and diarrhea are consistent with the malaria diagnosis. Unfortunately, her apparent intense drinking, really two glasses of scotch is
large
intense
glasses
drinking.
of scotch, please.
Yes. Did I say large?
You did.
Is doing her damaged cirrhotic liver no favors and may have kickstarted the reactivation of the parasite in her system. The low percentage of ring stages in her blood smear are also consistent with the low number of circulating infected erythrocytes characteristic of P. vivax infection. I hope this woman receives the proper care she needs to recover. Thanks again for the informative and entertaining podcast. Sincerely, David P.
Right.
All right, the last one is from Chris. There's a lot going on. Best lead immediately seems to be parasitemia observed by a blood smear. Intracellular ring bring to mind couple of AP complexes, Plasmodium and Babesia. If this were malaria, I would expect at least to see a recurring fever, but this is not reported. Malaria transmission does still occur in Nepal, but not in Kathmandu, so I feel comfortable excluding this from a differential. Babesia, however, is a tick-borne parasite endemic to Long Island, where this patient was recently camping. Potential transmission is present. Onset agree with the incubation period. Symptoms are consistent. Other GI symptoms are not typical of this infection, may be due to stress or unrelated causes. Heme-sustained blood smear should be diagnostic. B. microti is the most common species, transmitted by deer tick, typically the nymph, small enough so could easily avoid detection. Combination drugs recommended, but I'll spare everyone the trouble by not listing them all here. Another interesting case. I hope I approached it from the correct angle. Chris is in Athens, Georgia. 8 guesses, not bad for August, gentlemen.
Very good.
Really good, Daniel. I'm very impressed by our listeners.
I am as well.
And they're from all over.
What does that have to do with anything?
That has plenty to do with it.
They have one thing in common. They listen to TWiP.
They do.
The worldwide reach of the show, right?
There you go. There you go.
Well, Daniel, what do we have to say now?
Well, we still have 2 more people that have to guess to bring our total up to 10. So,
all right.
We already have books, so we're not concerned about this one.
Yeah, you're not in the random number generation.
No, we're not. No, we're not.
But I mean, I'll point out the couple things I thought were helpful. One is Dickson seems to keep harping on the fact that there's no malaria in Kathmandu, so that's actually helpful. And
some others did too.
And when I was when I was working right at Beer Hospital in Kathmandu many years back, you would not see malaria in the local people living in Kathmandu. It would be people who would be coming to the hospital from southern low-lying areas of Nepal that would be the malaria endemic. So that is important. And we would make this distinction. You'd ask the geographical history right off. Are you coming in from the mountains where you have a high incidence of Salmonella typhi infection? Or are you coming up from the south where you have a high incidence of malaria? Because we had, limited diagnostics back then. So that I think is relatively important. I also thought the 4%, the less than 4% comment. So I'm going to throw that. So Dickson?
Yes.
What do you think?
Well, I would agree with the majority opinion here that Babesia sounds like the most likely cause of her illness. Together with the fact that she's on immunosuppressive medicines and has had a history of ITP, it all seems to point in that direction. By the way, if it's P. vivax or ovale, the hypnozoite stage lasts for about 5 years, and that's it. So that's on the cusp of not being relevant to this case because she was there in 2005, right? And now it's 2017, so that's a little bit more than 5 years.
Well, I guess 2017 she was back for a couple months, but...
Well, yeah, but I agree also that there's no fever, for instance, but that might be a factor to think about. The drug might be affecting her ability to generate a fever. No, but I think the simplest explanation is Babesia.
You don't think there's another infection going on?
No, I think ehrlichiosis is a real possibility. In fact, everybody seems to know that I like to fish now because I've actually said this many times on the air. So, I have a good friend, who I used to fish with regularly. His name is Paul Dickson. And, it was kind of weird because Dickson, people started with this Dixon, that's his name. And so, he actually developed a triple infection. He had babesiosis, he had ehrlichiosis, and he had Lyme disease all at once from the same tick probably, and got very, 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 very sick and almost died. And never forgot it. And every time I saw him after that, he continued to regale me on his symptoms of what it felt like to be triply infected. So it's all possible and with ticks, because as we will see with our paper, ticks are really efficient carriers of infections.
All right, and Vincent, because as we all recognize, you have become the master parasitologist.
You have. No. We both agree.
I am an imposter.
No, you're not. You're just new. You're a novitiate. You're a novitiate.
Impostara scapularis. I think Babesia is very clear here because the rings are the right percentage, and because the Plasmodium is simply not something that you would find in Kathmandu. I think that's compelling. I don't think it explains everything, but as Kevin said, it explains most. And there may be other things going on.
Yeah, the lack of Maltese crosses here is not a disturbance for me because the parasite goes through stages of infection just like malarial parasites, and that's probably not always present. And it might be a species that we're not familiar with because there are over 60 of them, by the way. I don't know how many of them are found on Long Island, but the lack of a Maltese cross is not it's not off-putting for me.
Yeah, no, I think that's important, actually, right? So when this case first came in, it just came in a few weeks ago. I shouldn't say it came in. When this woman came in just a few weeks ago to the hospital, it was in the evening, which is when people love to come in when the clinical parasitologists have gone home.
Just before you're about to leave for home, that's right.
And that was one of the things that troubled the initial person was, we're looking at this blood smear. It's a little less than 4%. We're seeing lots of ring forms, and I didn't mention some of them are extracellular, which is also helpful too.
Right.
The other, I think, as we go into so we are thinking of a apicomplexan here, and we're initially thinking, boy, could this be malaria? Because I don't want to, maybe she didn't tell us, but she took a trip to an area when she was in Nepal where there was malaria endemic. Maybe this is Vivax ovale or something. I was not thinking, initially of falciparum, and part of it is the timing. It wouldn't make a lot of sense for, a year ago I got exposed to falciparum, and now I'm acutely ill. So the malarias you're thinking about are Vivax and ovale. When you're seeing with Vivax and ovale, you usually only see 1 or 2%. So when you get up to the 3 to 4%, and we've talked about why, the malariae tends to only go after the older erythrocytes, so we see only 1 or 2% there. The Vivax ovale only goes after the young erythrocytes, so we only see about 1 or 2% there. It's only the Knowlesi and the falciparum that get higher percentages when you're thinking of malaria. So the percent of less than 4%, hopefully steered some people in that direction. The lack of Maltese crosses, that is, as disease goes along, you start seeing those. So seeing someone come in acutely ill, you may not see Maltese crosses, and that shouldn't really sway people away from considering the diagnosis. Exactly. If you also, I guess I would say, if you're seeing, 3-4%, you're seeing so many forms with Vivax and ovale, you tend to not just see the ring forms, you actually tend to see some of the other forms. And so that came up, that issue that we talked about, or one of our emailers wrote in about, with the ovale, you're going to see these tiny Schiffner's dots. With the Vivax, you're going to see slightly larger, darker James's dots. But when you're getting, 3-4%, you say, maybe there's some reason why it's above what we would expect. But if you're seeing that many ring forms and you're only seeing ring forms, that would initially argue against that.
Yeah.
I think there's a lot that told us before we had confirmation, which we then end up having. So the parasitologists come in the next morning and they review the properly prepared blood smears. And, morphologically, it's identified as Babesia. And actually, a PCR was quickly done and also confirmed the Babesia microti diagnosis.
Bingo. I would like to add something for the confusion of the Schiffners and Joneses or Jameses or whatever. Those are not on the cell itself. Those are not dots of anything. They're actual indentations of the membrane of the red cell, which collects the dye from the Giemsa stain, and that's why it looks like a dot, but it's actually a depression induced by the infection itself. So when you say Schiffner's dots or James's dots, they look like dots because of the stain, but if you looked at this, let's say under an electron microscope, you could actually see that the surface of the red cell is completely altered by the presence of these parasites. And so you get these little pits where the stain can collect. As you wash off the excess stain, the little pits retain the stain, and that's what it's all about. And I think, by the way, that Schiffner's dots are in Vivax, because that's the most commonly seen malaria. At least it used to be. And James's, I've never heard of James's. I've never actually heard that term before, to be honest with you. So,
yeah, I think of it as sort of archaic, and as I think I mentioned to our list, I can't tell them apart if you don't tell me ahead of time. And then even
important.
if you look, yeah, it's just there's these little dots.
Right,
they're characteristic of ovale.
Sure.
And clinically, we take the two subspecies of ovale, so Curtis, walkeri, and vivax. We just put them together. Geographically, they're a little bit different as far as where you see them because the Duffy antigen and some other factors.
Yeah.
But in general, we treat them, we consider them to be relatively similar. Presentation, hypnozoites, etc.
Yeah, they both relapse. That's the main point about those two.
Exactly. And, and we've talked on earlier episodes, people used to just say, oh, it's the falciparum, that's the one that kills everyone. But if you look worldwide, it's
not
probably
true.
Equal. Yeah. It's probably seeing many deaths from these other types of malaria as well. So,
and we also used to think that falciparum was the only one that was drug resistant, but actually the Vivax is resistant now too in Indonesia and places like that. So you have to rethink the whole deal. I mean, it's a constantly changing environment, basically, right?
Yeah, and and the other things that we'll throw in. So in addition to this, we didn't just stop here. We did serological testing for other types of infections that might be transmitted. And fortunately, this woman had just the Babesia. She did receive antibiotics initially in the ER and was continued on broad spectrum antibiotics until the blood cultures came back negative, because with the eosinopenia, with the high white count, with the impaired cognitive status, it wasn't clear that she didn't also have a secondary bacterial sepsis.
Right.
But she actually did quite well. And a few days later, it was clear, lucid, and was able to be discharged.
I have a question. I'm sorry.
Jump in.
No,
I was going to go back to having scotch. That's what she could do.
Yeah, I was going to say, well, let's talk about that for a moment, because she does have some signs of fatty liver degeneration due to cirrhosis. Was she recommended for counseling or something afterwards?
So I'll say a couple interesting things that are come up here. We, and not just me and the two other of us on this podcast, but the initial descriptions of Babesia, the belief was that you had to have some immune compromise to be susceptible.
Yes, that's right. That's exactly right.
And so originally it was referred to, some of us still call it Nantucket fever. And if I remember, it was I believe, a Portuguese fisherman with out a spleen, right?
Yes,
who got the first described case.
Right.
And then we began to realize that people with spleens can actually get sick as well. People with immune compromise from others. I had a patient a few years back who got a transfusion. They had blood malignancy, and they ended up getting it from the blood transfusion. Now the blood is screened, at least in certain parts of our country. And so the issues that she has that compromise her immune system may be putting her more at risk of this. And I don't think she realized that the two drinks of scotch were an issue. So this was sort of in the larger picture,
right?
Things being addressed.
Right. Okay.
All right.
Okay.
Well, let's give away a book.
Let's do that.
Random number generator. Let's generate a number between 1 and 8.
I guess 1 and 9, including 8.
What?
Because there were 8 guesses, so if we're just doing between 1 and 8, then 1 and 8 don't get included. But anyway, ignore me now.
Oh, we got number 4. Let's see who got
number 4.
Who's number 4? I have to scroll down here. We have to go past the case history. Here we go. 1, 2, 3, 4 is Kevin in Chicago.
Okay, Kevin.
Kevin, send us your address to TWiP@microbe.tv. We'll send you an autographed copy of PD6.
There you go. Kevin, looks like you could have written the book. Perhaps
next time you should get Kevin on it.
He's very thorough in his clinical descriptions.
He wants you to add tick-borne encephalitis virus to Chapter 39.
Well, we will be assiduous.
Let's get on it.
We're going to do that, actually.
Our paper today is about Babesia microti.
What?
How about that?
How
do you think that Daniel, who picked this paper, did this on purpose? It's published in Frontiers in Microbiology. Endosymbionts alter larva to nymph transstadial transmission of Babesia microti and Rhiphencephalus hemophysioloides.
You're close.
Rhipicephalus?
Rhipicephalus.
Rhipicephalus hemophysioloides. I think if you can say these things quickly, it's impressive.
Rhipicephalus hemophysioloides.
Hemophysioloides, not FASA.
That's fine.
Ticks. They're ticks. Rhipicephalus hemophysioloides are ticks. By Lanhua Li Yizhang Danzhu and Xiaonong Zhu from hemophysioloides. Weifang Medical University and the Chinese Center for Disease Control and Prevention in Shanghai. And they're both, well, Weifang is different from Shanghai. Now, the thing here is so cool that these ticks that transmit Babesia to our unfortunate 70-year-old camper, by the way, the lesson from that incident is don't go camping. Stay inside.
Yes. Close that window.
Close that window. No, that's not true. That is not true.
These ticks have endosymbionts.
They do.
Dickson, it is reminiscent of TWiP, where we talk about mosquitoes and their endosymbionts.
That's right.
Wolbachia.
There you go.
These are bacteria that live inside the cells of the tick or the mosquito.
Right.
You know, I was about to say insect. Would that have been correct?
No.
See, that's not, because ticks are not insects, are they?
Arthropods.
Dickson and I had a long discussion today, Daniel, about insects,
descriptive
arthropods, and arachnids,
that's right,
of which ticks are, right?
They are.
Ticks, spiders, scorpions,
and mites.
And mites are arachnids,
They are.
which are also arthropods.
Correct.
Did you know that, Daniel?
You know, we have a whole section of our textbook.
Yeah, actually, I referred to it to show Vincent exactly which groups are parts.
Arachnids have 8 legs.
Yeah, the arthropods just mean jointed legs. That's all that means, jointed legs. So you can include crustaceans.
Like lobsters and crabs.
Yeah, that's right. And millipedes and centipedes and all kinds of other groups of jointed-legged insects.
What's the little funny statement about a millipede centa?
Oh, that was an answer to a question that the guy couldn't actually answer. So he says, well, I do know a joke about millipedes and centipedes. They asked him what the difference was between those two groups. Of course, the number of legs, but in this case, he says, if a millipede a pint and a centipede a quart, how much would a precipice? Imagine that on a PhD oral. This is an oral examination during your PhD thesis work. And all 5 questioners just cracked up and they said, okay, we'll take a break here for a Coke. They came back and they asked him some questions that were more relevant to his background.
So these ticks, which are arthropods with 8 legs, they have a diverse group of symbiotic microorganisms, including Rickettsia, Coxiella, Francisella, Arsenophilus,
keep going,
Candidatus, Midichloriae mitochondriae, and Wolbachia. So Candidatus means it's a candidate genus. And I think it's fascinating that it's midichloriae, because one of the dumbest Star Wars stories ever was about midichlorians in the bloodstream giving these Jedi their powers. And now I know that
ruined it.
He got the name from this.
No.
I didn't realize he got the name from midichloriae. Or maybe the people who wanted to submit this as a candidate did it. I don't know which came first. Anyway, so lots of these ticks have these, and some of them have 100%.
Not lots, all of them.
They all have something.
That, you learn something by looking at something from China. I've never read a paper about ticks from China before, so this is an eye-opener for me. And to realize that you go out and collect ticks for laboratory work and you can't avoid these endosymbionts. Everybody's got them.
And they want to know what they're doing there. What is their effect on transmission of, say, babesiosis, right?
That's one of their questions.
We know that Wolbachia in mosquitoes will prevent virus replication.
And protozoan replication. And worm transmission. This is a generalized effect.
Didn't we do a paper where they treated a a worm infection with an antibiotic because it targets the Wolbachia.
That's correct.
Whatever the
Onchocerca volvulus, and they have Wolbachia. That's right. So
they have this. They say that this hasn't been studied much in ticks.
That was a different. By the way, I just wanted to.
Of course.
For this, they say, wait a minute, you just changed gears on us here. The Wolbachia are actually responsible for the pathology that Onchocerca induces. So curing them of their Wolbachia,
yes, you're right,
dumbs it down to just an ordinary infection.
Yeah, so it's the opposite of what is happening with Wolbachia.
Yes, that's correct. Here. That is right. They didn't mention Wolbachia in these ticks, though, but I would have been curious to see what it...
Well, they did. They say there are Wolbachia. And
no, but they didn't use them in their study.
Not in their study.
No.
Not in their study.
No.
Now, before we talk about this, I had a lot of questions about the life cycle.
Ah, right.
And this word Transstadial, I say it in the German way, but Transstadial transmission.
Right.
So a tick, does a female tick need to take a blood meal in order to lay eggs?
Yes.
Oh, just like mosquitoes.
That's right.
All right, so the female lays eggs. What happens next, Dickson?
Well, the eggs are laid on the forest floor usually, or a sylvatic environment of some sort. The eggs then develop inside, and then they hatch. Now they're known as larvae.
Mm-hmm.
And the larvae have to take blood meals in order to advance to the next stage.
Yeah.
And when they take one blood meal, it's usually from a rodent.
But wait, they're on a larva on a forest floor.
They are. So that any small mammal that happens by is susceptible to attack.
They leap onto it.
Well, they're not leapers, basically. They're just slow.
Crawlers?
Yeah, they quest. They quest a lot.
Do they crawl up blades of grass?
Well, or a little... These things are so small, they're the size of the head of a pin. They're incredibly small.
How many ticks could you put on the head of a pin, Dick?
Well, it depends on how many... no, let's not go there.
That's a joke because usually we say how many viruses fit on the head of a pin.
Or how many angels can we fit on the head of a pin. That's right. That was an old
So you could put one tick on the head of a pin.
You could put one tick larva on the head of a pin.
Daniel, do you have ticks in your backyard?
We do. We have. Well, I mean, it's amazing the spread. And we used to say, "Oh, you only have to worry about the deer ticks, the dog ticks. You don't have to worry." But now the dog ticks, we're starting to see Rocky Mountain spotted fever right here in this region. So all the ticks are causing trouble.
You've actually had a lot of Rocky Mountain spotted fever on Long Island.
Yeah,
for a long time. For a long time, actually.
Yeah, actually, how many years ago? I want to say about 10 years now. One of my stepsister's daughters, I guess that makes her my step niece or something. She had Rocky Mountain spotted fever. Actually, was quite ill, hospitalized in the city, and it took them a little bit of time. And one of the challenges, I think, is they refer to it as Rocky Mountain spotted fever, but often the rash, the spotted part, doesn't come until a bit later. So if you're waiting to think about that in your differential, you can actually delay your treatment. So that's sort of an important pearl.
Yep.
Do you tell your kids to be vigilant when they go in the backyard, or do they never go in the backyard? While I was up in Canada with my wife and 3 kids this last week, we were in the national park up there, and they have a sign, tick warnings, Lyme disease, etc. And, my wife turned to me, she said, "You know what? We spend so much time outdoors. I would be shocked if we haven't all been infected multiple times." And I said, that's probably true. And I refer to one of the early studies when I was in high school, my parents tried to gravitate, I think, to living in areas where it was like high infection rates. I'm not sure why. So, first we moved to Greenwich Village in the early 80s, right? It was a big epidemic there. Then we moved to a little town on the Connecticut River called Lyme. And so...
Let's see. They named a disease after that place, I recall.
Apparently they did. And I remember one of the early studies where they asked the question, so we're seeing these children, right, the index cases that really got people to focus on the initial identification. But then they did a serological study looking at a population in the immediate area and saying, well, what percent of the people here have been exposed? It was like 80%.
Right.
So I think a lot of people get exposed, but it's only a minority that actually get ill.
That is true.
So my wife's probably right because we spend a ton of time outdoors.
Yeah. And you have pets.
And we have 2 at the moment. We have our Cocker Spaniel, and now we're puppy raising a service dog. So
right.
3 children, 2 dogs, lots of outdoor activities.
Do you tick check your dogs regularly?
Check.
So They are.
Or are they wearing collars with?
They actually they have an oral and there's a topical treatment that they're required to have. But both of them are black-haired dogs, meaning it's
brother.
Near.
You'll never see them. You'll never see them. No.
So the experiment is quite simple. They're going to say, treat females with antibiotics and see if the offspring are able to acquire Babesia and Rickettsia.
Right.
So they take adult ticks, they allow them to feed on a rabbit and become engorged, and then they get really big, and then they can inject them with either PBS, ciprofloxacin, or kanamycin. And Dickson and I were reminiscing, they use Hamilton syringes.
They're precision instruments.
Precision syringes.
They were wonderful.
They're made of glass.
Yes. With
a metal needle, right? Which is very fine.
It is.
And you can get them in 1 microliter total or 10 microliter, whatever
amazing.
You want. You can really put small amounts and they put it in the tick. And then they allow the female to lay eggs.
Right.
They become larvae.
Yep.
And they look to see which ones have Coxiella and Rickettsia in them.
That's right. They call them Coxiella-like.
And Rickettsia-like.
Like
right?
endosymbionts, LE. Like they're not exactly Coxiella, but they resemble them.
Right.
And the other ones resemble.
So the first experiment or the first question, what is the effect of giving the mother antibiotics on these bacteria in the larvae?
Right.
They do that by PCR.
Right.
And what they find is that the density of Rickettsia is lower in both CAN and Cipro treated groups. Correct? Am I getting that right?
That is correct.
Coxiella was lower in the CAN treated group.
Right.
But Cipro and PBS were pretty much the same.
That's right.
Now, Daniel, does that make sense in terms of your vast knowledge of antimicrobial susceptibility?
I guess we should help people with these antibiotics who maybe are not using them every day, like some of us. Your ciprofloxacin, your Cipro, people are probably familiar with this, often used for urinary tract infections, other types of infections, is a fluoroquinolone antibiotic, and it's going to target the DNA gyrase, and it's going to have different effects on different microbes. Kanamycin is a aminoglycoside. It's going to actually target the ribosome. So, basically what you're seeing here is targeting the ribosome is going to affect both the Rickettsia and the Coxiella. The DNA gyrase activity, you're not going to see a lot of benefit with targeting Coxiella, but you're going to see benefit against the Rickettsial species. It is similar to what we would see clinically with these drugs.
Is it right, if I remember correctly, that Cipro was used to treat the anthrax patients during the post 9/11 thing?
It was, and part of the reason they did that was that when you weaponize anthrax, it's hard to weaponize it and make it Cipro resistant, which is why. So your normal wild type anthrax, you could use other drugs, but specifically the weaponized, they recommended Cipro for that fact.
Mm-hmm.
We had a whole TWiP on weaponization.
Yes, we did.
This past Friday.
Yes, fascinating. It was fascinating.
I'm going to have to listen. I find that stuff fascinating.
Yep.
Well, this gentleman had gone to the Soviet Union after they shut down the bioweapon lab, and he worked in one.
Right. Exactly.
Lots of cool. In fact, one of the people who he recommended a book on biocrimes.
Okay.
And the guy listened, and he wrote an email.
Really?
He gave me a link to get a free copy of the book.
I'll be darned.
Because he said, this is a government publication, he said, and someone's charging for it on Amazon, but it's free, and here's the link.
Wow.
It's very cool.
Wow.
Yeah. So, speaking of that, Coxiella, so Q fever was actually one of the 8 main bioweaponized organisms by the U.S. government. And so it's actually kind of interesting. Bring that up.
It's quite interesting. I went to Rocky Mountain Labs. Remember Dickson? That was
Who could
in Montana.
forget?
And previous to our trip, I interviewed Robert Heinzen, who works on Q fever and Coxiella burnetii. And that's a TWiP episode. And it's really interesting. It's a high-level containment pathogen.
What is the lethality of that infection in general population when it was running?
It still is a...
Can it kill you?
So it can kill you, and it's still prevalent in certain parts of the world. Australia still sees a significant number of cases, and it can be an airborne transmission and actually can travel quite a few miles in some cases.
Yeah.
So it could be lethal. It could be highly transmissible. As you can understand, this is why it was considered.
But this is not Coxiella burnetii in these endosymbionts.
No, they look a lot like them, and they have the same.
He told me that most cows are infected with Coxiella burnetii. Yeah, and so it's in milk.
And why is it called Q fever again? Because it was isolated first in Queens?
No.
But there was one organism that was isolated in Queens, and I keep mixing them up.
Let's see why it's called Q fever. Now, I should remember from my...
I don't remember.
Interview with him, but I don't. So let's look it up.
And so we're going to save you a lot of letter writing right now by looking this up. So you
history.
Don't have to
we'll look at history.
That's good.
Q stands for query and was applied at a time when the causative agent was unknown.
Okay.
Coxiella burnetii. Frank Burnett and Harold Cox.
Okay.
Separately isolated it.
Okay.
And that's why it's Coxiella burnetii.
There you go.
Anyway, listen to that TWiP. It's really an interesting episode. TWiP, Q fever. We'll put a link in the show notes. Here it is. TWiP special. Q fever with Robert Heinzen.
Look at that.
So the cool thing is, this is a little digression, but it's good. This is an endosymbiont. They don't grow well, but Robert Heinzen's lab figured out how to grow it by itself.
Wow.
In culture.
Cell-free.
He figured out the culture conditions. Yes.
It's amazing.
That's what he's famous for. And now you can grow it on its own and do genetics and so forth.
Yes.
So the field has grown.
Yeah. Is it an enriched media compared to most?
Very enriched.
Right. So,
and I've forgotten what the key was, but there was one key thing.
So Bill Traeger at Rockefeller also figured out how to grow malaria cell-free.
Falciparum?
Yeah. Mm-hmm. Yep.
And one of the things was low oxygen, right?
Low oxygen, definitely right. And they used an extract of red cells, and they really had to make it rich in order to get them to grow.
Sorry, I'm sorry, everyone who's listening. I know you've left.
It's not really.
Come back now. We're going to get back to the paper.
That's right.
I would think like sometimes we go off on tangents like the bio weaponization. I mean, I think people find that fascinating. And this is an organism where it only may take between 1 to 10 organisms to infect a person. So it is very, not the Coxiella like that we're dealing with here, but the Coxiella burnetii we're alluding to is an incredibly frightening pathogen.
Right. But that's not what they're studying here, because in the tick, they are not pathogens, they're endosymbionts.
Right.
So that's very interesting.
They want to know, is there any effect on Babesia?
Right.
So we've already shown that the antibiotics can affect the number of, or the amount of Babesia in the larval tick. Then they put these larvae on mice that have been infected with Babesia. They call them the larvae of each tick were used to infest B. microti positive mice.
Infest means it's a kind of an old world term rather than infect, because they actually don't become inside the host. They're ectoparasites. They take their blood and then they fall off.
Take 24 nymphs from each maternal tick. Remember, the mothers have been treated with antibiotic, and now they take control groups and the groups treated with each of the 2 antibiotics and allow them to bite mice who are infected with Babesia.
Right. To see if they become less, the same, or more effective vectors of Babesia in the presence or absence of their endosymbionts.
And then they wait a while.
Right there. That's right. They have to wait for it to develop
into a
nymph. Right.
And then they look for B. microti.
B. microti, that's right. So just as a point of reference to say what the life cycle of the tick is, you were asking me to walk you through that before. Then we got sidetracked. Of course, we do that all the time. So the egg of the tick then sits on the ground. It's been fertilized, of course, because the ticks have to mate. And then the embryo develops inside the egg. Then it hatches into a larval form of tick, which only has 3 pairs of legs, by the way. And then it needs to advance to the next stage. It needs to suck blood. So it usually interrupts the life cycle of a small rodent briefly, takes a little blood, and then falls off. That's enough blood to get it to the next stage, which is the nymphal stage. And apparently the organism, the B. microti, advances inside the tick as it advances through its incomplete metamorphosis life cycle, so that by the time it's a nymph, it has enough B. microti to cause an infection in another host, which would be another mammal.
So they fall off the mice and they pick them up and look for Babesia.
Right.
So Daniel, what did they find?
So I this is the exciting, I think, conclusion of the paper.
This is the nut of the paper. That's right.
It gets less interesting if you don't just stop here. But what they found is that if you treat with PBS or ciprofloxacin, the number that are going to be positive, they say, is 17, 18. But then with the kanamycin, the number is more than twice that, goes up to 46.
Right.
So this is the prevalence of the microti in the nymphs from the different treatment groups. So somehow it appears that when you treat with kanamycin, you greatly increase the number of these nymphs that are going to be positive for microti.
Aren't you concluding also that the kanamycin knocked off the Coxiella-like endosymbiont, which was in competition with B. microti? And then when the competition is gone, up comes the protozoan infection.
Maybe.
Well, I would say 2 things. You know what? You're making a few leaps there. I am. So, but that's the conclusion they want you to believe or take away from here is that the Coxiella endosymbiont, right? I don't know if anyone here watches Stargate or SG-1 or anything, but this idea that these endosymbionts are living in the ticks, like I guess the larval ghoul forms are in the Jaffa, right? They're making them stronger and healthier and resistant to Babesia. When you kill it with the aminoglycoside antibiotic, now the ticks are more susceptible. But, I think that's where they want you to make. But we have a couple confounders here, right? One is we're not sure if it's opening up a niche, if there's some sort of immune boost that's the endosymbiont is giving, or, boy, kanamycin is a broad spectrum antibiotic. Is it messing with the microbiome of the tick? Is it really the Coxiella that we're after?
That's right.
So that's a little bit of you almost want some sort of a more targeted, so you could just get rid of the Coxiella, or maybe even add it back to show.
Adding back would be good.
Adding back would be great. Take Coxiella negative larvae, infect half, and then let them all feed on B. microti infected mice and see who becomes more infected.
Yeah. So. And
they say it's not Rickettsia, which I would agree with that based on the differential of the 2 antibiotics, right?
Yeah, that's right. That's right. So it's hard to imagine how Coxiella could interfere with the development of a protozoan. But remember, this protozoan is an obligate intracellular parasite in all of its stages of life cycle. So the definitive host for Babesia is the tick, because it harbors the sexual stages, just like malaria is. Mosquito is the definitive host for malaria.
What kind of cells is it in, Dickson?
It's in the reproductive cells, and it's in lots of other cells also. But when it says transstadial, the tick reproductive organs are not necessarily the same as you would imagine, let's say, for a typical insect, which this is not. Right? So I believe if you looked up the morphology of ticks, you'd find that they had stadial cells. And these cells are the cells that give rise to the the eggs rather, and also permit intracellular parasites to be transmitted from mother to young. So that's the basis for the confusing term in the title.
I would like to know the mechanism. First of all, we nailed that it's Coxiella, as we said before.
Right.
And if it is, then what's the mechanism?
That's right.
Even with Wolbachia in mosquitoes, the antiviral effect
that's right.
We don't know the mechanism. Nope. It would be interesting to know. And if I were working still, I would want to know that.
Yeah.
Even if I weren't working, I would want to know it. But I am still working.
If you could obtain pure Coxiella-like endosymbionts and then do extracts of them to see which portion of that microbe is responsible.
And grow them in culture according to Robert Heinzen's procedure.
Yes,
you could make a knockout library of every gene.
Look.
And see which gene is necessary for this effect on Babesia.
Is he aware of this paper?
Should I send it to him?
Yes, absolutely. No, do it.
All right. I'm going to send it and say, we just talked about this on TWiP. Here's a link to the episode, and here's a link to the paper. Go after it.
Remember, they named that whole laboratory after a disease that's rarely found out there. Rocky Mountain spotted fever is hardly found in the place where they established a national laboratory to investigate the outbreak. So, and they're all aware of that, of course. And there's a good reason for going back and revisiting ticks.
Ticks. There's a good choice, Daniel. Nice paper.
Yeah, it was.
I like it.
Very nice. Now, do you agree with our laboratory approach to finding out the mechanism of what's going on here? Or do you have other thoughts that you would have done differently that could have answered a different question, perhaps?
Who, me?
You.
Are you asking me? Or
you.
Vincent?
No, you. Come on, you're still doing lab work.
I concur. No, it's interesting. It makes me always think of, we think of pathogens, or we think of microbes, microorganisms as pathogens.
Yes.
And I think the more we're starting to learn is that, no, there actually is a relationship here. And I like papers like this where they're basically demonstrating that certain microorganisms that are living in the ticks are critical for the tick's health, and so I'm now going to be searching for some sort of endosymbionts that I can implant in myself, to live longer and prosper. So
right, but I'm not convinced that Babesia microte has a health effect on the tick.
Yeah, we don't know.
What I think is going on here is you've got two intracellular parasites fighting it out for the same host. This is, that's my host. No, that's my host. And so, if you look at the origin of the discovery of antibiotics, for instance, and you wonder what the hell were these things doing in the soil to begin with?
Yep.
They're marking out territory for this microbe by saying, you can't come over here because this is my territory. I want the resources here. So they squirt this stuff out in the environment, and that prevents another microbe from moving into their territory, right? So it's like these nature shows where you see the cheetahs marking their territory or the lions are marking their territory, and you go into that territory and you get killed. But this is the same thing inside of a cell. If a parasite, an endosymbiont, as they're calling them, is already there, and here comes another interloper into the scene, the next thing you know, you're going to have some problems there, right? So there's a great segue, by the way, to our hero.
What's your hero?
The hero.
Segue.
The hero.
Segue.
I will.
Segaway.
Segaway. And here
That's a thing you ride on.
It is. Well, our hero just happens to be one of the greatest malariologists that ever lived. His name is Percy Cyril Claude Garnham. He was trained as an MD. He's English by birth and by choice. He stayed there, is what I meant. And his years of life ranged from 1901 at birth to 1994. So I had the privilege of meeting this gentleman when he visited the National Institutes of Health. I was at that point visiting with Dr. Robert Gwadz, one of the authors of our book, and in walks PCC Garnham, with lots of stories about new species of malaria, etc. And Garnham and Gwadz collaborated together on some research which identified the hypnozoite as the resting stage for Plasmodium vivax. So there's a great connection here with his interest in microscopy, the field of parasitology, of course. So I'll just read what I wrote about this, but I think there's a longer biography in everyone's future if you want to know more about this person. He was an incredibly productive person. Garnham was a generalist conducting laboratory and field-based research on leishmaniasis, toxoplasmosis, and malaria. Working with Henry Short and a host of other colleagues, the group discovered the hypnozoite, the stage responsible for relapses of infection with Plasmodium vivax. Garnham also produced a wealth of publications on non-primate and non-human primate malarias, in addition to those affecting humans. His book, Malaria Parasites and Other Hemosporidia, remains a classic in the field of malariology, and I happen to own a copy of that book. It's fabulously illustrated with colored pencil drawings of these malaria parasites and various species of hosts, reptiles, birds, and
I'd like
of course,
to see that.
I would happy to show it to you, actually. And it's remarkable, the contributions that he made. I'm surprised that he was not knighted. He was that well respected by his peers.
When he was 90, he was called the world's greatest parasitologist.
Yeah, and rightly so. He was careful. He was assiduous. He was generous. He was collaborative. He wasn't any, he didn't have any characteristics of a socially negative person. He was willing to listen to anyone, including students that just started their programs, to those that
when you turn 90, I will call you the world's greatest parasitologist.
Oh, you would? No, well, that's very generous, but I would refuse the title. I love the subject, though. I do love the subject, and he did too. You can tell when you sat down with him and looked in his eyes, you could see the spark of. I
don't know, Daniel. Doesn't it
science.
sound all like we're describing Dickson here? He was a nice guy. He never had bad words. He had a fire in his eye.
Come on. I'm
Daniel,
starting to blush.
I think Dickson fits it. Daniel, you have a case for us?
I do.
All right.
I hope everybody is ready. We're going to be heading back to Thailand. There's always like a sort of an arc of where I go with these things. So now we're going to head back to Thailand. And this is a Thai housewife. And her complaint is that she has multiple red bumps on her body that are associated with intense itching, and it's worse at night. Now, these are located on her head, on her legs, on the upper part of her chest. She also reports that she doesn't feel well. She says she feels feverish, she has muscle aches, and she has some difficulty breathing. So we go back a little, and she says that she, her husband, and kids had moved into a residence which had previously been abandoned several months before, and about 3 days after they had moved in was when she started to develop these symptoms. She described this abandoned residence that they moved into as a place where there was a lot of coconut husks around. Apparently the people who'd lived there before had been making mattresses out of the coconut fibers. Apparently that's a thing. And her husband, as well as the children that were living here, they started to develop similar symptoms, not as severe as the housewife. No medical history, no prior surgery. She doesn't have any allergies we're aware of. We mentioned that the other family members have similar complaints, but there's no family history of diseases that runs in her family. She doesn't take any medications. As mentioned, occupation housewife, and just sort of interesting, like a housewife in other parts of the world. She stays most of the time in the home and takes care of the family. And as far as her social history, she's living in this residence, which has been abandoned by people before them, and described as lots of these coconut husks around. There's a bunch of these unused mattresses that had been left sort of abandoned behind. There actually are several rat nests as well. So this is not a particularly posh setting. No poured out starboard home here. She doesn't have any toxic habits that she reports. No travel, just living in this immediate area outside of Bangkok. Doesn't have any pets. Now on exam, she isn't febrile. She doesn't appear toxic. She's a little bit of an increase in her heart rate, breathing comfortably though. She does, and a significant on exam, she's got these multiple red sort of bumps. We'll call them papules. And when you look at them, they have a central punctum to them, sort of like a small little excavated area. And she has these scattered particularly on the head, the arms, the upper chest. Labs are relatively unremarkable. No anemia, normal white count, platelets in the high normal range. The differential is actually, relatively unremarkable with about 6% eosinophils, right? Which will put that not eosinopenic, not eosinophilia, just normal amount of eosinophils, but they're present. And the thing I'm going to tell you is that the diagnostic test is we're going to do a skin scraping from one of these lesions on the chest. And we're also going to, it's going to be like sort of a Dr. House thing too, is that individuals are actually going to go into this setting and examine the setting to try to figure out if there's any connection between the environment and this woman's complaints, as well as, I guess, the complaints of her family members.
Tell us a little more about this house. Is it a dirt floor?
It's wooden floor. It's raised up a little bit. It's not a dirt floor.
Okay. It's raised above the ground. It's not above water or anything like that, right?
It's not far from the canal area. So,
all right. And what kind of roof? Is it thatched or wood?
It's a thatched roof. So it's
okay.
And you said nobody else in her family, just she?
No. I was actually saying her husband and kids are all similar complaints, but
okay.
not quite as severe.
Okay, fine.
You got it?
Yeah, I think so.
All right. And what does the husband do?
He goes out and works different things. It wasn't very clear what exactly his occupation was.
But he goes out and
he goes. He and the kids are. Yeah, she's the one who's in the home the majority of the time, and I will say seems to be the most affected.
And do they sleep on the floor?
They do. They sleep on these thin mattresses on the floor.
The thin mattresses with coconut leaves in them. Is that right?
They actually use the husk fibers.
Right.
Okay.
By the way, that's also very popular in hydroponic farming, to use the fiber from the coconut husk as a solid matrix for these seedlings to get them to start to grow. They have no nutritional value whatsoever, but they do hold the seed in place and convince it that it's in soil so that they can shoot out their roots. And that's what they start these plants with a lot of times. So they're being shipped around the world. That's the point. Because coconuts don't come from everywhere.
There you go. The Thai housewife with red bumps.
The family with red bumps.
Go for it. Well, she went for the exam, not the rest of the family.
That's right. That's right.
All right. Let's do 2 emails because they're both on the same topic and they're interesting. Daniel, can you take that first one from Jean?
Jean writes regarding TWiP 149. I'm a physician assistant and graduate of the Bangkok School of Tropical Medicine.
Nice.
This is right here, Bangkok, we're talking about.
Yes.
So I used to practice on the small Hawaiian island of Lanai. I now live in exotic central Wisconsin, but I'm lucky enough to still have a place in Lanai City. About 3 years ago, I first started noticing the large African snails in my garden. I was aware that they were a vector of A. cantonensis,
yes,
as are my Hawaiian residents.
Yes.
I read because I have been advised by the locals to just smash them. I'm concerned because this merely perpetuates the life cycle when the rats eat the smashed snails. I have been dropping the snails in a bleach solution, which I assume kills the worms. Please spread the word. Don't smash them, bleach them. Thanks, and I'll pass on the salad.
You should.
Dickson, you made
They're huge.
They're huge, 4 inches in diameter?
They were imported because in their native habitat where they're from, I believe they're African in origin, they eat snails. They eat smaller snails. So smaller snails were eating all the decorative plants in Hawaii, so they decided on biological control measure. So they imported these large snails to eat the small snails in Hawaii. Instead, they started to eat the plants also. They had an opposite effect of what they expected.
Don't smash them, bleach them. Do you think that's okay, Dickson? Does it kill the worms?
It kills everything. I think Clorox will zap everything.
Thanks, and I'll pass on the salad. All right, our other one is from Robert. Greetings, TWiPos. I subscribe to the AVMA Veterinary Medicine Update. And this just came by. Rat lungworm is prevalent in snails and slugs throughout Hawaii and will become more widely distributed at higher elevations as the climate warms, a study finds. Researchers at the University of Hawaii at Manoa say people should wash produce thoroughly, inspect and clean greens 1 leaf at a time, and plant native plants. It makes you reevaluate your place in the world.
That's right.
And he sends, Robert sends a link to the study and the Maui Now article.
Yeah.
Well, if you are Gene, you will pass on the salad. But if you're Robert, maybe you'll wash it. All right, that's it for TWiP 157. You can find it at microbe.tv/TWiP, wherever fine podcasts are distributed, free of charge. For example, if you have a phone or a tablet, you have a player for your podcasts, like, well, the one I use is called Overcast at overcast.fm. Very fine podcast, but there are many others. Just search for TWiP. Make sure it's This Week in Parasitism, and please subscribe so that we have many, many people subscribing.
Indeed.
If you like what we do, consider supporting us financially. Go to microbe.tv/contribute. There are a number of ways you can do that. And, of course, send your question, comments, and guesses for this month's case to TWiP at microbe.tv. Daniel Griffin is at Columbia University Irving Medical Center and ParasitesWithoutBorders.com. Thanks, Daniel.
A pleasure as always.
Dickson Despommier is at Trichinella.org and thelivingriver.org. Thank you, Dickson.
You're welcome, Vincent.
Dickson is sitting next to me today.
I am.
Because his iPad crashed and he couldn't see the show notes, so he's sharing mine.
It's fine.
And it's fine, right, Dickson? We can get into a fight.
Not yet.
I'm Vincent Racaniello. You can find me at virology.ws. Thanks to ASM for their support and Ronald Jenkins for the music. You've been listening to This Week in Parasitism. Thanks for joining us. We'll be back soon. Another TWiP
is parasitic.